Okay, so we are from the group 16. So this is our parameter. So which is the first mass is 1150 kg and the second mass is 1200 kg. And then for the first design, we have three stiff coefficient couplers, which is K1, K2 and K3. So K1 we are taking in between 350, and then the K2 is 150, and then the K3 is 550. For the second design, we are choose 350 Newton per meter. So now we are going to the ANSYS. So we already do the model A and the model B. So now I would like to show the model A first. So first of all, we have to go to the geometry and the right click. We have to click the edit geometry in design modeler. So we can see that we already have the pop-up like this. So according to the density and the mass, we can find the volume. So this is the volume that we are get, and then we can create two type of cube, and then this is the dimension for the cube A. So after sketch everything, we will get the two cube like this. Cube like this. Okay, now back to this page. Now we have to go to the model, right click, and we have to tap the edit. So we will pop up another screen like this. So from here we can see the model is already here, and then we have to put all the spring. Okay, now we have to put the connection ground to solid, solid to solid, and ground to solid. So ground to solid is this one. We can see the stiffness is 3.5 times 10 power of 3 because we are using in the kilonewton. And then this one is for the second spring at the middle, and the third one is at the end of the cube. So the coordinate system is we have to put 1.5, and then we have no y and z axis. So once we are complete, put all the connection, we have to apply mesh like this. So after apply the mesh like this, and then we have to apply remote displacement for the cube 1, and then remote displacement for the cube 2. And then finally we have to put the solution. So from here we can see the deformation of the spring like this. This is the first deformation, and then this is the second deformation. So this deformation is for the first design. So now I would like to show the second design. So this is the model B. Same like before, you have to go to the geometry, right click, and edit geometry in design modeler. So we will get like this. So for the second model also, you have to put all the dimension to get the cube. So once done, we back to the home page and go to the model, right click and edit. So this is the model for the second cube. You have to already apply that the method is structural steel, and then the connection, as I said before, we have to put 3 spring, ground to solid, solid to solid, and ground to solid. Now we can see that the 3 springs have same stiffness. So once we are done, we put back the mesh on the cube, and then we can do the remote displacement 1 and remote displacement 2, and then the final you'll get the total deformation. So this is the first total deformation, and then this is the second deformation. So now we are back to the first model. So we can see the solution information. Okay, so from here, the mode 1 is 3.02 frequency, I mean hertz, and then for the mode 2 is 4.07 hertz. And for the second drawing, okay, we will get for the first mode you will get the 2.74 hertz, and then for the second is 4.75 hertz. So from here we can conclude that the model tool and the theoretical tool, the results are almost same.